Okay, welcome to the second video in the Heathkit build series. Sorry it took so long to get to the second video, but I had a number of things come up, including this. So, yeah. Anyway, we're going to be doing the backplane circuit board today. The instructions talk about going through and making sure you've got all the parts. And all the parts come out of pack 2. And like I covered last time, we've got an instruction sheet that says where all the parts are. Pack 2 is in this section of the box right here. So let's get those parts out and go from there. Okay. We've got the backplane, which is where all the cards go. Hasn't been touched in 30 years. That's kind of cool. Okay. All of our parts. It's kind of neat because they've got part numbers on the bags, so you can order if you need to, or could at one point anyway, all the parts you needed. Package of pins. Let's set that out of the way. These are our ISA card connectors. It's a bent pin in one. I've got to fix that at some point. Oh, there's a couple of them. Okay, then we've got our discrete components. And let's make sure that we have everything that we need here. Handy dandy pencil. Okay, we got 3 560 ohm resistors, which are green, blue, brown. And they actually tell you right there, green, blue, brown. That's not it. And there we have a green, blue, brown, but it looks green, black, brown. I don't know if you can see that really well. So there's one of those 3. And there is the second one. And there is the third one. Check that off. Next we're looking for 2 1500 ohms or 1.5K, and these are brown, green, red. Brown, green, red, like so. I'm going to separate these out so they're easier to spot. There's 2 of those. Okay. 5 ohm 10 watt wire wound, which is this monster here. And glass ceramic. Oh yeah, I'm gonna need the magnifying glass for that one, boys. Actually, I think I have to bring out the big guns. Okay. Yep, this is the glass ceramic. And there's one 2.2 microfarad electrolytic. That's a 3.3 or 33. That is a 33. And there's our 2.2. And we have 8 33s. So there is 2 of them. 3, 4, 5, 6, 7, 8. Okay. And then there's a 47 microfarad electrolytic, which is that dude right there. Next, we have 5 green LEDs. 1, 2, 3, 4, 5. Okay, and then we have a 79 LO5 integrated circuit, and I'm going to assume that is it. And that part number, yeah, it's right there, 79 LO5. The part number tells me, or makes me suspect anyway, that this is a 5-volt voltage regulator. Normally the 5-volt voltage regulators that I see are 7805, which is in a TO220 package. And this is a TO92, I think. Okay, and we have our backplane circuit board. We have a female connector shell, which is right here. We have 16 male pins in that bag there. And 8 circuit board connectors. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we start putting this monster together. I should note that when you're building a kit this old and you've got all original parts, it might be a good idea to replace these electrolytic capacitors because they do dry out over time and may not function the way they should. I'm taking a risk here, assuming that they're going to be good, primarily because I want to keep it as original as possible, and I'm cheap. Sorry about the furnace, there's not a whole lot I can do about that, but hopefully it's not too loud in the audio. Okay, let's kind of move things out of the way here a bit. Now the first thing it wants you to take a look at is the pictorial diagram. And they have provided this thing. Then you remember this from last time. And they have breakouts of how everything looks. And this helps you identify what the parts look like. The board, and they break the board into sections, okay, showing where all the parts are. And they, when you're putting parts on the board, they'll refer to such and such for section 2 or section 3 or whatever. And that's what it's talking about. And there we go. Okay, so let's get started. Get my soldering iron turned on. And we're going to have to go get some of that awesome original solder from the kit. And let's see who is first. Okay, C117 on section 3. And if you remember, section 3 was this area here. And C113, or 117, is that little bit right there. And that's where that glass ceramic capacitor goes. So get those leads bent over like so. Insert in the board. And you move the wiring apart like so, just to make it easier gets the parts held in place the way they're supposed to be. Get all the crap off this poor iron. Come on. Care for how that flowed. Well, it's okay, I guess. Not fantastic, but this isn't a production shop, so you get what you get. Leaves trimmed off. Right back. Okay, the next is a 560 ohm resistor, and it goes into R101, which is right there. And they also want you to do the next four here. Okay, so R101 is that 560 ohm resistor. Blue-brown. Grab one of those. And I like to keep them all oriented the same way if possible. Just makes for a neater installation. Again, we spread the leads a little bit to hold them in the board. And R102 is a 1500 ohm, which is the brown, green, red. Three is another brown, green, red. Brown, green, red, 1500 ohm. 1.5 K ohms. And yeah, I bend my leads a little bad, so components aren't centered the way they should be, and it looks kind of dumb, but I'm not out for perfect here. I'm out for getting the job done. And 104 is a 560 ohm. Actually make little lead benders that you can use. They're made out of plastic that are good for doing stuff like this. I've actually got a tool for it floating around here somewhere. But that tool is not designed for doing pad links this narrow. Let's see if I can't find it. Here it is. It's a lead bender. You put the leads right in here and hold it down, or as you push it down, it bends the leads. You know, and you can use these to locate the holes in the circuit board like so. And then when you put your part in there and hold it, you just bend your leads over and you're done. I've used it once, which is pretty sad, but that's just the way it works. And this is R105. Okay. I'm going to resort back to my magnifiers when I'm doing this because I just don't see well enough to do this easily. I suppose you're having fun looking at the back of my head, but it is what it is at this point. You want high production values, go to HBO. Let's scatter stuff everywhere as I'm doing this. I have to look pretty close to the board because I'm wearing a special magnifier on my glasses. Because without that magnifier, I really can't see these things well enough to solder them up. Here we go. Those are all the resistors. Let's not get leads all over the room. Okay, that little chore took nearly an hour to finish. There's well over 60 pins per and 8 connectors, so yeah, it took a while. But there we go. And of course, then the furnace turns on. Yeah, one thing that hadn't dawned on me when I was complaining about how the solder flowed is each connection I had a problem with was one of these ground plane pads that had a huge copper pore on it, and it acts like a heat sink, and I had to turn the iron temperature up to to prevent the copper from drawing all the heat away from the solder joint. And once I did that, things started working a lot better. Okay, now we are up to this part where we're doing the connector shell. So let's go ahead and get all these pins out. Set this right here. And again, there's somebody actually wrote the part number on here. And then we have our connector shell. And this is kind of curious. It's it's basically a Molex pin. But normally I'm used to seeing these as crimps, not solder on, so that's kind of interesting. It's a, I don't know how well that'll focus, but you can see what that thing looks like. And it wants 15 of these things inserted into the connector shell. It says when you insert a pin into the hole, press it into the hole until you hear a faint latching click. Then gently pull on the end of the pin to make sure it is locked into place. which means I need pliers. Oh look, pliers. Probably don't want to push on that. We're just going to put them all in. Gently draw them through. I don't want to pull so hard on the connector that it deforms it. Careful as to how I do these. It worked out pretty well too. I can push it from behind. Although pulling it runs less risk of damaging the solder tail on the connector. Said there was only going to be one extra, and it looks like there's two extra, which is okay. Normally it's not good to have extra parts, but they say you're going to have extra. Well, by God, you're going to have extra. Okay, so talks about the orientation of the connector shell, and it wants those two little keyways, and you can see there's one here and there's one here, oriented such that it goes in there. So again, it talks about how I do the sockets. You're going to do 2 quarter pins and then get the rest of it all happy and lined up. A squared board, yep. Okay. Oh, I need my eye on. The monocular is just awesome. Or monocle, maybe? I don't know what it's called. Huge ground pores. Okay. Got those 2 done. A few more to go. better angle on these pins. Clean the soldering iron tip frequently. Good ground pour. It's either ground pour or a positive bus, one of the two. It'd be kind of fun to reach out to the guy that designed the board. Talk to him about the process he went through designing it, getting it laid out, things like that. I mean, now we've got nice little tools like Eagle and KeyCat or KiCat or whatever it's called to do board layouts. And back when this was laid out, digital layout systems were far and few between, if they existed at all, and very, very expensive, I suspect. Okay, that part's done. What do we have on the next page? Circuit board checkout. We're looking for unsoldered connections, poor solder connections, solder bridges, protruding leads could touch together. Check the tantalum capacitors for proper positioning of the positive end. Well, that's kind of curious because there's no tantalum capacitors on this board. So, yeah, okay. We did the LED. What is that? I wonder why it calls it an LED IC for proper installation. Maybe they wanted to do and. This is no, 102, 104, 106, 8, 9, 11, 13, and 15 are not used on this board. And we've got 102, 104, 106, 108, 109, 111, and 113 and 115 are not used. And it says this completes the circuit board assembly. Set it aside until it's called for later. And I'm going to do that. And that's going to end, whoops, this chapter of the build. Turn around so you guys can read the lettering on the foil side. 1984. It's 31 years old. Awesome. Thanks for watching, guys. Sorry it's kind of boring.